Okay, today we're going to take rational functions a step further and start solving them. So we're going to use a lot of the properties we've discussed prior and a lot of the techniques we've used to solve other types of equations to get through these. So for our first one, it says to solve 4 over x plus 3 plus 5/6 minus 23 over 18. First thing we're going to need to do is get these fractions into something that we can work with. So what we're probably going to want to do is to have a common denominator. So there's a couple ways we could do this. We could either rewrite every fraction as a common denominator and then deal with them from there, or if we multiply the entire equation by the common denominator, we'll have the same effect without having quite so many steps. So first thing we need to do is find that common denominator. Right, so our common denominator is going to have an x plus 3 in it. It's going to have a 6 in it. And it's going to have an 18 in it. 18 already has the factor of 6, so we just need a factor of 3, because that'll give me the 18 that this guy needs, and I'll still have the 6 that this guy needs. So my common denominator is 18x plus 30, 54, or 18 x plus 3. That might be an easier way to look at it. So let's multiply this entire equation by 18 times x plus 3. So if I multiply this by my first term, the x plus 3's cancel, and I'm going to have 4 times 18. Plus, if I multiply 5 over 6 by 18 times x plus 3, 6 goes into 18 3 times, so I'm going to have my 5, and I'm going to multiply by 3 times x plus 3 because the 6 goes into 18 3 times and reduces that a little bit. And then equals, I'm going to take out the 18, I'm going to have 23 times x plus 3. So this is what the numerators would look like if we had a common denominator. But if I have a common denominator across both sides of an equation, I don't need to have it at all, right? Because I could just cancel it all out. So that's kind of where we're at. Now let's just combine and simplify what we have here. So we've got 4 times 18, which is 72, plus 15 times x plus 3, so 15x plus 45 equals 23x plus 69. So I have x's on both sides. Let's subtract 15. So I'm going to have on my right side, 23 minus 15 is 8x. If I combine my numbers on the left side, 72 plus 45 is 117, minus the 69 from the right side is 48. Divide both sides by 8. X will be 6. It says to check our solution. So if we plug that back into check, we're going to have 4 over x plus 3, or 9, plus 5/6 equals 23 eighteenths. 18 over here would be the common denominator, right? Multiply 9 by 2, multiply the top by 2, multiplied 6 by 3, multiply the top by 3. 8 plus 15 is indeed 23 eighteenths, so it works. Okay, the big key here is we multiplied everything by our common denominator. Okay, let's try it again. Let's build the common denominator first. I'm going to need an x plus 3, excuse me, and a 2. And I need a 10, but there's already a factor of 2, so I only needed the 5 because 2 times 5 is 10. And I still have the 2 from that guy. Okay, so my common denominator is 10 times x plus 3. So I need to multiply each one of these fractions by that in the numerator, right? Because when I multiply by the bottom, they cancel. So let's actually write all that out. This will be the step I did not show last time. So I'm multiplying the first fraction by 10 times x plus 3. But the x plus 3's cancel, and I just have 2 times 10, which is 20. Okay. Then I multiply this fraction, 3 over 2 times 10 times x plus 3. 2 goes into 10 5 times. Now it's 3 times 5 times x plus 3, or 15 times x plus 3. And then I do the last one, 19 tenths times 10 times x plus 3. The 10s cancel, and I'm left with 19 times x plus 3. So you can see how the denominators go away in each of the three fractions, and that was the point. That's why multiplying by the common denominator was what we wanted to do. That leaves us with just the numerators. And then again, we're just going to combine like terms and solve this guy. So 20 plus 15x plus 45 equals 19x. And 19 times 3, well, 20 times 3 would be 60, minus 3, so 57. Let's subtract 15x from both sides. So I'll have 4x on the right. Those will be gone. I've got 20 plus 45. That's 65 on the left. Minus 57 should be 8. X will be 2. Notice it keeps saying to check our solution. We're going to keep doing that, and there's an important reason why coming up here in a second. So if I just copy it down, but with my 3 involved, this makes this a 5, right? So my common denominator between 5 and 2 is 10. So multiplied that by 2, this is 4 tenths. Multiplied this by 2, it's 5, or by 5, so that's 15, equals 19 tenths. So 4 plus 15 is 19 tenths, so it does indeed work. Okay, I want you to try this one on your own. So pause the video for 2 or 3 minutes, tackle this one, and then come back and we'll see if we got it right. Okay, we need a common denominator. My common denominator is going to be 12 times x minus 4, and I need a 48, but of 48, I already have 12, and 12 is a factor of 48, so I just need another 4. So really, it's 48 times x minus 4 is my common denominator. So when I multiply this by each one of these fractions, the denominator will go away, and I will be left with the numerator multiplied by a new factor. So 48 and 12 goes into 48 4 times. So I'm really multiplying 7 by 4 times x minus 4. So 4 times 7 is 28 x minus 4. The x minus 4s will cancel here. It'll be 48 times 9. And then 48's cancel. It's going to be 55 times x minus 4. If that's kind of confusing, go ahead and write it all out every step like I did back here and show this cancellation. That might help a lot. I'm just going to save some room by not doing it. I'm hoping that me talking through it kind of shows you what's happening. So this is 28x minus 28 times 4, which is 112, plus 48 times 9 is 432, equals 55x minus 55 times 9, which is 495. Subtract 28x from all sides to get them on the left, or excuse me, on the right. Negative 112 plus 432 should be 320. So 320 equals 55 minus 28 in our x's is going to be 27x minus 495. So then 320 plus the 495 is 815 equals 27x, and I'm going to hope that that's divisible by 27, so that when we divide both of these sides by 27, we will get just 30.2. Okay, sometimes what we have to watch out for are extraneous solutions. So this is why checking is so key. And here's where we're going to see an example of an extraneous solution. So I need a common denominator. The first thing we have to do, though, is factor this to see what its factors are. So that's x and x. Factors of 15 that add up to 8 are 3 and 5. Well, that's good news because that is the common denominator, right? Excuse me. So I'm going to have to multiply the first fraction here by an x plus 3, and this last one by an x plus 5, but the middle one can stay the way it is. So I'm going to multiply this guy by an x. Well, I'm multiplying everything by this is what I'm doing. So in the first one, the x plus 5's cancel. I'm going to keep 2x times x plus 3 minus this one. The entire denominator cancels, and I just keep what I had before. So this is really important that we have these parentheses, because otherwise we're going to have double negatives, and we don't want to get those all mixed up. Okay, so I'm going to keep that in parentheses for right now, because we are subtracting this whole thing. Equals, and this last one, the x plus 3's cancel, leaving with just the x plus 5, so 3 times x plus 5. Now this next step is simplifying, and this is where we're going to see why we have extraneous solutions. Right here in this step, we are about to create a factor of x squared that we did not have before. We've talked about when you create higher powers, you end up with extraneous solutions. So because the degree goes up. So right here, 2x times x is 2x squared plus 6x minus x squared minus negative x, so plus x, and minus negative 10, so plus 10, is equal to 3x plus 15. We have a quadratic, so I want everything on the left side. 2x squared minus x squared is x squared. 6x plus x is 7x minus 3x is 4x. And I have a 10 here. Minus 15 is negative 5 equals 0. We're going to try and factor this first. If we can't, we'll use the quadratic formula. X factors of 5 that add up to 4, I think positive 5 and negative 1. So x could be negative 5 or 1. And the question is, which one of these will work, or will they both work? So let's plug them back into the original. So up here, 2x. So let's do the negative 5 first. That's too big. So negative 10 over negative 5 plus 5. That's 0. I don't even have to write the whole thing out. That's already a big problem, right? I can't be negative 5 because I'll have a factor of 0. We know that down here, that's a solution to this too. So that's also going to give me a factor of 0. This one would work just fine, but I can't divide by 0, so it can't be that one. If I plug in a 1, we're going to end up with 2 over 6. That looks okay. Minus, let's see, 1 minus 1 minus 10. It'll be negative 10 on top, divided by 1 plus 8 plus 15. 9 plus 15, 24, equals 3 over 4. So this is 1/3. I'm subtracting a negative, so I'm really adding. If I simplify that, divide by 2, I get 5/12. Looks like 12 will be my common denominator, so I'll multiply this by 4. 4/12 plus 5/12 is equal to, this needs to be 12, so 9/12. 4 plus 5 is 9. It works. X plus 1 is our solution. That x minus 5 was created right here when we created a higher degree than the original function had. Yes, it had an x squared, but we created another x squared out of nowhere. And that helps to create extraneous solutions. Okay, last two, you're on your own for this one. Pause for 5 minutes and then come back. Okay, really hoping you guys paused and actually tried these instead of just continued watching, but here we go. My common denominator here is going to have a y minus 2. This is over 1, so that we don't have to worry about, and a 6, right? So when I multiply through, the y minus 2 goes away. I get 5 times 6, which is 30. Plus 2 is going to get the entire denominator because there's nothing for it. So 2 times 6 times y minus 2 equals, the 6's will cancel, and I'll have 17 times y minus 2. So over here, 30 plus 12y minus 24 equals 17y minus 34. 30 minus 24 is 6. Let's subtract 12y, so we get positive y's on the right. 6 equals 5y minus 34. Add 34 to both sides. 40 equals 5y. 8 would have to be y. I would be more particular about checking anytime there's x squareds. You should get in the habit of always checking. I know for a fact that 8 does work. Over here, my common denominator is going to have a z plus 1, a z minus 1. And if I factor this guy, I'm going to find that it's z plus 1 minus 1. That's a difference of squares. So that is the common denominator, which is nice. So on the left, multiply by the common denominator, the z plus 1s cancel. 2 times z minus 1 minus the 1. The z minus 1's cancel, so I'm just going to have z plus 1. I'm going to keep it in parentheses because I'm subtracting and then I've got a negative, so I got to be careful. Equals, that is the common denominator, so just negative 2 because the common denominator will take care of what I'm multiplying by. So I have 2z minus 2 minus z, and I'm subtracting the 1, so minus 1 equals negative 2. 2z minus z is z. Negative 2 minus 1 is negative 3 equals negative 2. Let's add 3. Z equals 1. Again, we did not increase the degree of the function, so I did not introduce any extraneous solutions. But anytime you do that, it's incredibly important that we check for extraneous solutions because there's almost definitely going to be some. Good luck on the homework and have a great day.